Final presentation today is from Carl Lund, who's another partner at LabKey. He's our development manager. And it is the evolution of connectivity to LabKey server. And I think this is definitely a common theme across a lot of the presentations so far today. People wiring up, say, new data sources, whether that's coming from LIMS like FreeserWorks or Freezer Pro or sample-minded or things like that. Or ETL-based systems coming in from some other database solution, as well as then data out to downstream tools, whether that's our reports or other APIs or existing third-party analysis tools.
All right, great. Can everyone hear me? So good job, everyone. We made it through the end of the presentation. Where we go. So I'm going to be talking about connectivity and integrating your scientific. For the past 11 years, we've been working on tools at LabKey that help get data into the server, trying to lower the barrier to connect scientific data. A lot of the times, when people first start using LabKey, some of the early questions are, I have data existing. How do I get it into LabKey? Or I have machine data in the form of files. How does that come into LabKey? So we've been working on various tools that hopefully gives increased flexibility in routing data, cooperating with other systems. So playing nice with existing users' data or with other applications. Not trying to mandate that all data needs to live within LabKey server, and hopefully giving users more options. We're to the point now where there's many choices for how you get your data into LabKey, and sometimes for some of our older existing applications, there may be a better way to get in to import their data than they're currently using. So for this talk, I'm going to do a very high-level historical look at connectivity in LabKey. And I'm going to focus on some recent changes in the last couple years, particularly RedCap, Freezer Pro, and ETL. And then talk about some future directions, things that we're planning on working on, things that we're thinking about. Okay, so in 2003, this is actually this is the new branded logo from Fred Hutch. In 2003, it was a different logo, but LabKey had just gotten started, and we launched our first server, CPaaS. We were working with Martin McIntosh, loading proteomics data, and so we built a data pipeline, data analysis pipeline, which is still in use today. Built it out of Java, and we were using that to, import mass spec data and analyze it and load it into the database. So the particular applications that we're using that leverage the pipeline were very specific to the type of data, the format that we were trying to read, and also to the analysis that we were performing on it. We were also importing flow data, started working with flow cytometry data, and that was also coming in through the data pipeline as well. And then in that period of time, data entered into LabKey server could also be entered in through web form, standard form, and pushed into the back end. LabKey server was also the database of record, so meaning that all data that was exposed into LabKey had to live in our schemas, our tables. So if we look at sort of the landscape in that time period, we had data could come in largely through the pipeline, the Java pipeline, form entry. And we also had what we call Java modules modules. And so LabKey, for those of you who are familiar with LabKey, it's a module-based architecture. So the extensibility point is via Java modules. At that time, somebody could write author their own module and deploy onto a LabKey server, and they could write custom applications or their own analysis tools that could bring data in. So in 2006, we started partnership with Sharp to build the Atlas data portal. This was to do research on HIV and AIDS. So a lot of different data types were encountered in our partnership with Sharp. A lot of CRF data, a lot of specimen data, and assay data. So at this point, we started developing our study modules. We started developing assays. Study data came in either through the data pipeline or through form entry. Assay data came in through various pipelines. So we started working with, say, the neutralizing antibody, Luminex, ELISpot assays. As I mentioned before, we built the Assay framework, and this is a flexible framework that is modular in nature. One of the things that we built, we call internally GPAT, which stands for General Purpose Assay Type. It's basically an assay type that does no specialized analytics on the back, and so data can come in through either a tabular form or through spreadsheets. We added tools where you can create an assay by handing it a file. It'll look at the file and it will introspect it and say, well, you have these fields. Which of these fields you want to import, what types of data, and then create the assay under the covers and then bring your data in. We also discovered, working with Sharp, working on Atlas, that there was a need for a lot of custom applications, both developed by LabKey staff and developed by Sharp staff. What we discovered was that Java modules were difficult to author. They were fairly complex, and so if you weren't a LabKey developer or very experienced in Java, you had a very hard time getting traction in developing and deploying a module. Additionally, there was a need for custom applications that were somewhat lightweight, where you didn't really want the overhead of a module, but say you wanted a page that you wanted to have some application running, maybe to generate a report, some of what Raphael was showing earlier. So we started working on the LabKey API and what we call simple modules. So LabKey APIs, we started with JavaScript bindings. We added Java bindings and Sass as well. And so these things sort of help lower the extensibility barrier, and they also enabled users an easier pathway to get data into the server. So you could do things like insert, update, delete programmatically. You could write your own applications. The simple modules, we call them simple. They're basically file-based modules, and so you would create a module, and I think this is what Raphael's team uses largely, is file-based modules. You can have a little bit of HTML, you can have some JavaScript, and you can quickly build up a module and deploy it on a LabKey server without necessarily having to write Java code. So more geared towards people that were good at maybe a little bit of SQL, some JavaScript, maybe some R reporting, not necessarily writing Java-based modules. The other thing, one of the first features that we added in simple modules was the ability to have what we call, file-based assays. So you have you can participate in the Assay framework by easily writing and deploying an assay in this modular form. And then we also created the list infrastructure, and so lists are very simple table formats. It's a very powerful tool for if you have a rectangular tabular data or spreadsheet, you just want to get into LabKey, you want to start writing queries against it or join against other lists, and so this was added in that time period as well, and is still a very powerful feature in the platform. So now if we look at the summary in 2008, we added better support for file uploads, tabular data, spreadsheet data, come in either through to studies, assays, lists. Added the simple modules, so there was more of a choice for how you wanted to extend your server. You could either go the Java route or you can go the file-based route or the simple module route. And we added client APIs. So we had various language bindings. So in 2008, we started working on what we call our external schemas. And so external schemas are, say if you have data in a SQL Server or Postgres, something outside of LabKey, you want to connect to it. You don't necessarily want to import that data into LabKey. And so we added the support to sort of basically mirror the data from the external schema. So the interesting thing about this piece of work is that relocating the data into LabKey server is no longer required. And at the same time, LabKey security applied as well. So you can expose your external tables into LabKey. You get the security model applied to it. You can start writing queries against it. And also, if you wanted to configure it that way, you could also enable editing of the external tables through LabKey. And then these are our supported data sources. So SAS, Postgres, Microsoft SQL Server, Oracle, MySQL. At the same time, we also continued to refine our APIs. So the client APIs, we added more features to, say, the JavaScript API, additional language bindings for Perl and Python, and we continued to polish our module-based tools. At the same time, we added support for what we now call remote connections. So a remote connection is say another instance of LabKey server that you want to treat as an external source. And so you can go to Schema Browser and configure your remote source. So say if you have multiple LabKey instances that you want to connect up, and so the connection is through the LabKey server API. It's through our API level. It's not directly database to database. And then the way you expose that at the folder level, and so the usual LabKey security applies. Okay, so in 2012, this is what things look like as far as connectivity. So the additional language bindings to the client API, support for external data sources, and remote server support. So the last couple years have been fairly interesting. We started doing more work with what we call integration to external applications. And so one of those projects was, some might know, RedCap. So RedCap is an electronic data capture tool. It's a web application for building and managing online surveys. So it was developed and distributed by the Informatics Core at Vanderbilt. It's a freely available tool. It's very, very popular in the research and the academic community. It's very flexible. You can create longitudinal data. You can create demographics data sets. You can create online surveys and campaigns. It's very flexible. So we partnered with the University of Washington International Center of Excellence for Malaria Research, ICMR, as we call it. They were interested in integration with REDCap, and so the university was using REDCap to store the demographics and clinical data for their malaria research in REDCap. And they were interested in having the REDCap data integrated into their study data so they could do visualizations, queries, and integration with their existing experimental data that has come in through various forms of assays, some of the other assays that they're using. So one of the requirements was that the data needed to be synchronized. And so the staff at ICMR, they liked using REDCap. They liked flexibility. They wanted to continue using it. REDCap is a great tool. And so what we did was we hooked into the API layer. And so REDCap has a very good API that allows another program to export data directly. Data is extracted and saved in a form that is compatible with our study archive, and so it can come directly into LabKey. At the same time, we added scripts so that they could automatically import data on a regular basis, and they get, because it comes in through the pipeline, they have logging, they have auditing, there's email notifications when an error occurred or when an import was successful. Then the other external application was Freezer Pro. And so you heard John Rue talk about this earlier in his talk. Not going to spend too much time. I think he explained it's a commercial web application for frozen specimen management. And so we partnered with Novo Nordisk in this case to develop Freezer Pro integration. Going to kind of go through this slide fairly quickly because John gave a pretty good overview of what Novo Nordisk is doing. And so the net takeaway is they wanted their specimen inventory that was in Freezer Pro integrated into their study for many of the same reasons that ICMR wanted to integrate their REDCap data so they can do visualizations, integration queries. So so that there's Freezer Pro also has an API, and we're able to leverage that and have a integration point where data could be scheduled to LabKey server. Once you set up the Freezer Pro module, the data can be exported directly and synchronized. You can schedule when you want the import done. The data comes through the pipeline, and there's also a configuration that we support that can control, say, like filtering, mapping, whatnot. So the last thing that I wanted to talk about was the ETL framework, and so this is a feature that we're really excited about. ETL stands for extract, transform, and load. What it gives the users is the ability to another solution for bringing data into LabKey without the need to relocate their data, and provide any sort of transforms that need to be done along the way. So this was developed as part of Hydra. And the goals of building the LabKey server ETL framework, understanding the origins of the data, when and how it got there, auditing, of course, normal security, LabKey security, and flexible data integration strategy. So I'm running out of time here, so I'm going to go fast on some of these last slides. So ETL is built on top of pipelines. The basic functionality that we have right now, we have support for query-based ETL, stored procedures, remote sources, which is what I discussed a few slides ago, checkers, scheduling, and logging output. So ETLs are module-based, so you need to author a module in order to implement one. And each ETL consists of a set of transform steps. So you can chain different transform steps together as part of a single ETL. So the key components of a transform are sort of the source table or query. Where are you getting the data from? Where are you transferring the data to? How you are going to filter the data, your filter strategy. And scheduling. So different filter strategies, is basically what rows do I want to move to the target table? You just say select all, just get me all the data all the time. Another filter is sort of the last modified. You just want to get the newest data, with the most recent value. And then run-based filtering looks at a specific column that you use to choose which is the most recent one. So it's useful for run-based ETLing. And then target options. How to add data to your target table. Do you want to just overwrite what's existing, truncate, and just copy a whole new set in? Append, where we try to add only new rows and leave the existing rows alone, and then merge, update or insert matches on primary key. And then lastly, scheduling options. How do we run the transform, how often, when to run it. You can do a simple poll where we check at a predefined interval, say every hour, every 6 hours, 12 hours, or do something more specific, which is more like a cron option, where you want to run it at a specific time, at a specific day. So, so now, this is today, this is what our connectivity summary looks like. So we added support for external systems, RedCap and FreezerPro, and support for ETL. So for future directions, kind of what LabKey is currently planning on, and things that we're thinking about in the future. One, I think Hannah mentioned in her talk, DATStat is another type of external application that we're going to do a project on with children. It's an online tool, a commercial tool for data and study management. And I2B2. I2B2 is interesting. It's an informatics framework that pops up on our radar a lot, and so we don't have any concrete plans right now, but we started a couple of research projects just to investigate what I2B2 is. Is there an integration strategy there? And then last is cases. So I think Paul Fern mentioned cases in his talk. We already interact with cases a little bit with the Argos project, but what's interesting to us is in the case of cases, could we walk up to an existing cases schema and run an application over the top of it without necessarily massaging the data or requiring too much of the data? So that's something that we're thinking about. And that is the end of my slide deck. So any questions?
Does every ETL have its own module?
No, you can have multiple ETLs in a single module, but you sort of need the module to house the ETL. The ETLs are largely XML, and so if you wanted to author an ETL, what you would do is you would, say you had an existing module, you would place the XML files that contain the ETL definitions in the ETL directory in your resources folder, and the server would pick those up. ETL. So Argos is, I think Novo Nordisk is. We're currently doing a small project for the MacroRap lab to build a peptide inventory, and so we're using ETL. There's the PepDB database that lives on Sharp. The plan is to use ETL to mirror the data into the MacroRap peptide inventory module, so then they could do their own peptide inventory tracking on it. Okay, thank you.
All right, thanks, Carl. I think that shows, kind of some of the things we're doing on the platform side to enable, individual installations to set up their own ETLs and connectivity, as well as some of the specific integrations that we've already done with particular third-party packages. So that concludes the final presentation for today. We've got our panel discussion. We'll start at 4:15, so about 15, 20 minutes from now. Get the room reconfigured. Please take a break. And before you take off, walking back and forth, I've noticed there's a pretty significant temperature gradient in the room, which, being a software person, I will look you in the eye and tell you this is a feature, not a bug. And if you're warm, try flipping to this side. If you're cold, try flipping to that side. And hopefully we'll get it all balanced out.
So tell us at the beginning of the day, Josh.
Well, it was only recently discovered this feature. So see you back here in about 15 minutes.